Hey everyone. Yeah, thanks for the kind words. I will try to make this technical because one of my pet peeves is talks that don't get too technical, but I'll do what I can to make it accessible to. Don't know if that's exactly my strong suit, but I'll try. So yeah, I'm here today to talk to you about SYNTHETIX on Optimism, and I think it's a very interesting space, and we've been definitely working pretty hard along with Chainlink to bring together the synthetic experience on layer 2. I'd like to sort of walk you through a little bit of what we've been doing. So where are we right now? So Optimism has relaunched a public beta that many of you are probably aware of, and there are a few projects on there. There's SYNTHETIX, we have Uniswap, and now Chainlink as well. That's the current state of play. Now it's still a public beta, so not anyone, you can't just deploy on there just yet, but you can sort of submit a form and get out there, and the Optimistic team is slowly allowing people to get on there, trying to keep congestion to a minimum right now. So this is what it looks like right now. This is a Quinta. This is our DApp, where you can trade between synthetic US dollars to Ether, Bitcoin, and Link, right? It's up. It's been great. We're really happy with it. So give it a try. You basically, all you need to do is just go to quinta.io, and you can, it'll help you sort of plug into the Optimism network and MetaMask, and you can get going. So why do we at SYNTHETIX need another layer? What are the main reasons for it? So, I mean, the first one is obviously, as many would understand, is reducing gas consumption. SYNTHETIX is quite a complicated set of contracts, a lot of interrelated. We have this idea of a shared debt pool, and that means that there's a lot of constant interaction between what is SYNTHETIX whenever users mint or burn or trade, right? And so the advantage of going to another layer is that we can really bring down the gas consumption massively for users, right? So it's less cost to them. The next thing is obviously faster transaction throughput. We want to get users want to have a better experience of trading, like maybe what they would have in the traditional finance world. And waiting for 15-second block times is just not, it doesn't pass muster, right? So we want to actually be able to get users get very quick responses to their trades and actually be able to almost potentially sub-second reaction times. And then the final thing is just future-proofing the protocol, right? Like this is where Ethereum's going, right? We get Chainlink's coming. It's inevitable, sharding, optimistic rollups. We need to do this, and so it's just for us. It's pretty critical that we sort of move ahead early on and try to get ahead of the curve when it comes to getting onto layer 2. So why Optimism? Our choice is really bound around the fact that it's pretty much the closest layer 2 implementation to the current EVM, right? So we can reuse all the code that we have from layer 1 contracts in Solidity, which is obviously massive. If any of you, manage, maintain code bases, having different versions of code bases is a nightmare. It's not something you really want to have to do. So the closest we can get this to the EVM, the better. It also means, though, that we can reuse developer tooling in the EVM. So, hard hat and everything that the team at Nomic Labs have been doing is just incredible. And there's a bunch of developer tooling that has been written for the EVM that we can just use almost out of the box with the OVM, which is great. It's also a very likely candidate for ETH2 scaling. And then finally, the security that you get through L1 via rollups and fraud proofs on chain is very, very it's very paramount to what it is to be on Optimism. So for us, it's been a pretty critical choice. Cool. So in a nutshell, how does it work? Okay, so Optimism, and actually to some degree Arbitrum is quite similar to this as well. There's a single sequencer, and you access it like a provider, a URL. So very much like you would in Ethers or Web3, you would just put that custom provider in. And then, you as users can do things like I want to mint some SNX or transfer some SUSD, or I want to exchange some SYNTHETIX, right? Like trade, basically. So this is what happens on layer 2. And so what you'll also have is on layer 1, you have actions like if the user does a deposit, right? Then these things on the right, they're like contracts, like on layer 1, right? And so if a user does a deposit, it sort of goes into the contract on the right-hand side. And then the sequencer's job is to sequence things that happen on layer 2 with things that have happened on layer 1. So users depositing on layer 1 is something that has to end up on layer 2, right? So the sequencer's job is to sequence them together. And then finally, what the sequencer will do every sort of, inclusion period, which might be 5 to 10 minutes, it'll basically take all the summaries of all the transactions, persist it to layer 1, and then persist a state root hash, right? It's just like, what would the state be if this would change? So basically what it does is it takes all the load off layer 1 from actually doing any of the execution, right? And then it has a fraud-proof engine, which basically someone can say, hey, I don't believe that state root hash is actually what would happen if I were to apply that other transaction. So I'm not going to go into too much detail, but it's effectively at a high level how it works. Okay, so for us, right, like we had to make a choice. Do we deploy SYNTHETIX completely isolated on layer 2 and have it as a whole different system, or do we connect them up, layer 2 to layer 1? And for us, the whole idea of SYNTHETIX is this concept of a shared debt pool, right? People stake SNX and they can mint SUSD, which can be turned into other synths, and there's a big pool of debt. So there's a lot of value for us to connect the two layers together. So for us, in the SYNTHETIX protocol, we made the decision that we actually want these two layers, layer 1, layer 2, to actually interact. They're not separate systems completely. Uniswap is the opposite of that. Uniswap is, they have Uniswap on layer 1 and there's Uniswap on layer 2. And these are two different protocols. I mean, they might be the same code, but it's not like you're sending your LP tokens between layer 1 to layer 2. You basically need to take your tokens, you need to send them to layer 2, and then you can stake there separately. So whereas for us, we wanted to make a decision, we wanted to make the architectural choices so that we could actually do some communication between layer 1 and layer 2, and I'll explain that. So the first one is messaging, right? Like, how do you message between these two layers, right? So basically what it works is like this. So here we have like Ethereum layer 1, right? And we have our contracts, bridge to Optimism and a bridge escrow. And then the purple contract is Optimism's contract, right? So if a user says, hey, I want to initiate a deposit on layer 1, what they'll do is they'll call a function in our bridge to Optimism, right? Which will do two things. It'll send a message to this generic message sender, said, hey, the user wants to deposit. And then it will send the SNX that they've deposited to this escrow contract. And this is all on layer 1, right? But then what happens is on layer 2, you have this relayer who basically after a few minutes will say, oh, there's a message to send. Okay, I'm going to send that message through, which gets passed to the deposit, like we saw in an earlier slide, which gets sent to a messenger on L2, which then passes the messenger off to our bridge to base contract on layer 2. Right? So Optimism is basically allowing us to send any sort of data payload that we really want. In our case, deposit of SNX. So all SNX that exists on layer 2 is basically deposited into layer 1 and just held in escrow, right? And then the message goes across to layer 2 and the SNX is minted there. Now, when we're withdrawing, it's kind of the reverse of that. So on layer 2, what a user would do is say, oh, I want to initiate a withdrawal, right? So they're reaching out to the bridge to base contract and say, I'm going to initiate a withdrawal, right? Which then sends a message to the Optimism's messaging contract on layer 2. And then after a week, which is created to prevent DDoSing attacks, after a week, that message actually gets relayed onto layer 1, right? Through the Optimism's messenger contract, which then sends a message to our contract, which says, hey, finalize this user's withdrawal, which then tells the escrow contract, hey, I need you to send you the SNX, send the SNX off to this user. So this is the way we do message passing, right? On Optimism, which I believe is actually quite similar to Arbitrum, right? It's kind of basically take fairly generic messages and we send them between, and we have to wait a little bit of time. Even for deposits, it's not instantaneous. You still need to wait a little time because these are two different systems. They're not strictly connected as such. Now, yes, everything that happens on layer 2 is rolled up to layer 1, i.e. it's in a contract in layer 1, but it's not like layer 1 can say, hey, tell me what the state is in layer 2, right? In real time. It's not like layer 2 can say, I need to know what the state is right now. The messages have to be passed between them in order to communicate. Okay, the next thing is contract management, right? So how are we handling the fact that now we're deploying contracts on layer 1, with SYNTHETIX, and we're deploying contracts on layer 2, right? Now, the nice thing is, because as I said before, Optimism, the OVM, optimistic virtual machine is quite close to the EVM. We basically can just switch on the compiler we use. We take the contract source code and we say, if it's Optimism, take their compiler, which is a fork of, in our case, Sol-C 5.16, but they have it of all different versions of Sol-C. For the source file, we say if we're compiling with the OVM, let's do a slightly different version of SYNTHETIX. It's the mintable SYNTHETIX, right? And in our system, label it SYNTHETIX. So when you're coding, you're basically, or when you're a user thinking, okay, I want to deal with SYNTHETIX, you don't really care that the contract underlying is mintable SYNTHETIX or SYNTHETIX. You just really want to deal with SYNTHETIX. But the engineers and the protocol, the core contributors, they need to understand, hey, there's a version of SYNTHETIX that lives on L1, there's a version on L2, and they're slightly different. Because for SYNTHETIX to exist on layer 2, it has to be deposited layer 1. right? So we create this, base SYNTHETIX contract, which has the common functionality. SYNTHETIX does very specific L1 stuff, like minting every week when there's supply, when our inflation kicks in. And then layer 2, all it can basically do is it can mint SYNTHETIX whenever it's instructed to, right, from the deposit contract on L2. Right, so we use polymorphism in our code to basically refer to things that happen in SYNTHETIX, and we try not to ever say, as much as possible, never be saying if OVM do this, if not do that. We just basically say in OVM, SYNTHETIX is this contract, on L1 it's this contract. It conforms to the same interface, right? So it's polymorphic. A few gotchas with contract management. You do have the contract size limit that you have already on layer 1, but it's actually a little bit trickier on layer 2 because with the fraud-proof engine that exists in Optimism, you actually the OVM transpiler, that little tool I said before, the compiler, the Optimism Sol C, that actually adds a bit more bulk to your contracts. So it's actually a bit more tricky to get under the size limit. You also have opcodes that aren't allowed, like self-destruct, which is pretty much, I guess it's kind of a known thing now. So like most people have got away from self-destruct anyway. You can't use native ether. You have to use wrapped ETH, and block number and timestamp are actually the L1 blocks. They're not actually the L2 numbers. So you won't necessarily get the same fidelity that you used to in layer 1. Okay, so what about deployment and testing? So with deployment, we do sort of a similar thing, right? We just switch on whether or not it's OVM. We just switch on the providers, right? There's gas limit if you're using OVM and the gas price. We actually don't supply a gas limit or a gas price, and that's got to do with the way the OVM handles gas. We don't actually want to specify the limits or the prices. We want to let the chain tell us. And the reason why is a little complex, but it's effectively the fact that we're trying to use the paradigm, or Optimism is using the paradigm of the EVM on L2. But when you do something on layer 2, when a user says, I want to mint or transfer synth on layer 2, there's actually two types of gas. There's the gas to actually do the execution, right? If I want to mint or whatever on layer 2, that gets paid to the sequencer. But there's also the gas to pay the rollup, the summary of the action that has to live on L1. So what they've done with the help of Vitalik, has come up with a spec is actually encode using significant digits, right, of the gas limit. Actually encoded both the amount of gas required to pay for the L2 execution, which is known, but the L1 rollup gas is variable based on the fact that the price of gas on L1 is changing constantly. So when you're deploying or interacting with Optimism, as you might have noticed if you use any of the SYNTHETIX apps, you'll see that when it comes to an OVM, the gas limit is going to look a very unusual looking number, and the gas price is going to be very specific, 0.015. And that's determined by the algorithm that Optimism have figured based on how much gas you're going to cost on L2, plus how much is it going to cost given the current rates of gas on L1, right? But for all intents and purposes, it doesn't really matter if you're a protocol developer. As long as it works, it's fine, right? You don't have to tweak things, and in fact, you shouldn't. So we don't tweak it. We just basically, when we're deploying, we basically just use the defaults that the provider do, and ethers will just do it for you, which is amazing. Now, with testing, the nice thing with unit testing is it's pretty much the same source, right? Like these contracts are the same, and the OVM or the EVM, that basically we can do our testing in hard hat and actually not even worry. We can use a regular EVM node. We test out our mintable SYNTHETIX code in effectively L1, and it should all work, right, for unit tests, right? But then when we want to go a bit deeper, we go to integration tests. Well, we actually have 3 types. So one integration test on layer 1, we just do a high level L1 things. Can I mint? Can I burn? Can I claim? Exchange? And we use Geth, a regular Geth node. When it comes to layer 2, what we do is we use the tool that Optimism given in Docker, and it fires up their fork of Geth, right? And their sequencer, and then we can do mint, burn, claim, exchange on layer 2, right? And then for the final test, if we want, and we do, we actually want to do this situation where we test out deposits and withdrawals. So we fire both nodes up and actually test sending messages that, like I showed you before, a deposit and withdrawal, does it actually work? If we were to speed up time and we actually make sure that the message passing is going correct. So we have 3 types of integration tests, right? And it's a way of basically making sure the system is robust and lives no matter what, based on every factor we do. Final thing is ownership. And so what we've done is what actually Uniswap have done for ownership is instead of trying to deploy multi-sigs on layer 2, what we've done is actually lean on the fact that we can relay messages from layer 1 to layer 2, right? So we can take a message unit, a user in a multisig on layer 1 says, hey, I want to initiate some message, some data to some target, right? The multisig can relay it on L1. It gets sent to the messenger. And then in a few minutes later, the relay on L2 will actually send that message through the Optimism messenger that goes on to our contracts, which eventually tells the target, hey, as the owner, I want to do this action, right? The data gets decoded onto the target. It's a really nice, graceful solution. That way, you don't actually need to have multi-sigs on layer 2. You basically just, everything on layer 2 that is managed is owned by this contract, this owner relayer. And we just relay messages from L1 to L2 to do owner actions. Cool. So that's it. That's a pretty high level, but I try to get a little bit of depth there for you. That's kind of how we've done it. Any questions, you can hit me up on Twitter, and thanks very much for your time.
Thank you so much, Justin. I think you totally nailed the dynamic. It was technical, yet accessible, walked through the process. So very much appreciate your thoughts behind this and your work on it as well.